YouTube. Some might argue I have a short attention span, and I would agree. A little while back we had this water heater, 5 litre with a boiling element, basically for hot water for tea. I couldn't carry on with the video that I was planning to do because I had to rub spares off of it to repair another one. So obviously with open ends on the pipes, you put water in, it pours out. So that kind of didn't go anywhere. But also we had this boost converter, when we had it on 12 volt, actually wouldn't go above 60 volts. So I was a bit sad. So now we've got a new donor element system, and we have 24 volts. So this is a 10.8 kilowatt shower heater element, and I got rid of all the gubbins that we didn't need. So basically we got 2 elements here, probably for a low, medium and high setting depending on how they're connected up, and there was 2 massive relays inside and a joint negative. So we're going to test the resistance of these. I've already tested them, just can't remember what they are. I'll get the mega out and test it, and we're going to connect them in parallel so the resistance is lower. And what we're going to do is we're going to step the voltage up on the boost converter from obviously 24 volts, and we could do a series of tests to see at 24 volts how much heat can we produce in an hour, at 36, at 48, you know, and keep going up and up and up and up and up, and restart the test each time. But for now, what I think I'm going to do is I'm just going to put it on at 50 volts with the elements in parallel, and find a suitable water container and pump, and just see just how warm it gets. Some will have worked out the current used already, or current to be consumed by the element, and if we clip that on there, watching it through the camera again, and that on the negative or neutral, get a resistance of 9.69 ohms on that, and potato phone coming out again, 9.71 ohms on that. But if we join them together in parallel, you have to forgive me, it's a little bit crude, but we'll do for now. Connected in parallel, we get 4.84 ohms. Clever stuff. Just a quick check with the other element. You can actually see that this is 22.4 ohms, so we are going to see a considerable difference in the power pulled, and hopefully the hot water generation we could actually achieve potentially off grid. Right, so I'm almost there, except for I come across a problem which is no fault but my own, is I don't have a switch where I can just switch the 24 volt load off. If I switch everything off, then everything goes off. So I have to have a think, but I've got a pipe with a hole in. We're going to fill it up from the hose end, and when the water comes out there it'll be full. If this works and it warms up, you know, touch warm quite quickly, and we draw a nice high current, then I'll further this idea and get a pump and a reservoir sorted out for a further test. So I managed to connect it up by just disconnecting the load side and connecting up the 24 volt live multimeter. We tested it out and we are at 51 volts. So we're verging on dangerous territory here. Now I'm just going to find something to operate a switch. I might have a double pole switch we can just pop on there quickly. Ready to go. Double pole 20 amp switch, meant for AC, second hand. In place. It should hold up for this test. I'm going to stand back and turn this on. Do I want to turn this on? Yeah, go on then. Oh, okay, on. At 50 volts, 5 amps, 250 watt then, isn't it? At oh, I haven't planned this very well at all. Oh, I've broken the clip there. Okay, we just have to do it on the 50 volts, and that's 5 amps. Out of interest, Can we get this to focus today? Disagreement? No. I'll read it. It's only saying 8 amps there. Interesting. So I'm just going to leave this on for a bit and see how warm that gets. Potato phone, come on. Can we hear anything? No. I might jack it up a little bit. 5 amps, 50 volts must be, yeah, it's about 10 amps, 24, isn't it? So, interesting. Right, that was my bad. I hadn't actually turned up the constant current part of it, so it was just 24 volts at 5 amp. So that's interesting because we covered 2 tests already. So once we turn that up, we get 11 amp at 54 volts now. We're pulling, come on, please focus, 29 amps. 29.5 amps, which is right on the verge of the 30 amp fuse I have in there, so I don't know how long this is going to last for. If we go complete darkness, then come on phone, then we'll be in the trouble. It's certainly getting warm. Oh, and there we go. Oh no, it's come back on. I must have pushed the button. Nope. Oh, I have no idea what's going on there. I really want to be a sport, but I can't find my IR sensor, and also I don't. If I'm pulling 30 amp at 24 volts, then I'm putting a lot of strain on the cells that were over there. And I think what I want to do before I test at a higher voltage with more amps is actually double up some of my cells so there's less sag. I am noticing there's some sag on pack 8. There's nothing I can do about that. But the inverter's kicking out because it doesn't like the low voltage. But this thing is boiling. Here we go. Getting puffs of steam coming out there. Oh no, it's gone again. Oh! I'd say that was boiling. I'd definitely say that was boiling. It's doing a good job. And listen to the switch. We'll let the pack lights come back on, and listen to the switch when I turn it off. Ready? Oh dear. Doesn't like that, does it? Definitely arcing in that old switch there. But interestingly, the fan in this never actually got warm. So yeah, I'll definitely be furthering this, but I need to double up some cells before we go any further. That is epic. I didn't think it would boil. Yeah, dangerous stuff. Yeah, so yeah, quite interesting. I spent my evening just putting random stuff together and making water boil out of an old shower. Cool, I like it. I'm going to disconnect this now and go indoors. Yeah, thank you very much for watching. Please subscribe, comment, rate, and I'll see you in my next video. Cheers.